Hello everybody. Today we'll talk about the Spark limitations. Let's go to next slide. One of the limitation is the small file issue. So all we know that how the architecture works, right? So we have, let's say, this architecture, Spark architecture, we have head node or maybe driver node, and then you have workers. So what happens, right? That will have all the metadata information. So let's say you have 100K files. All the entries will be here: file path, where it is running, when it got created. All these kind of metadata will be on the head node. So let's say you have 100K, 200K file or 500K files. So managing those files will be a challenge. Managing those files will be a challenge. So generally the recommendation is that let's bundle them or compress them or maybe create a small files. Let's say for example, instead of creating 1 kilobyte, 10 kilobyte files, right? Let's create maybe 256 MB. Just a recommendation of 512 MB. These size file you can create. So what will happen, you have to club these small files and create a small file. So then less entry will be here in the driver node. Managing those will be easy and the processing will be fast. So that is the one of the issue on the Spark. Second is related to cost. So because in this Spark what happens, we use RAM, we use CPU cycle. We want to process the data as much as possible fast, so that means you need more RAM and more CPU. So that CPU translates into cost, so it's just a little bit costly. Manual optimization. So what happens once you write a Spark code, the developer also take that in mind, how much CPU he is going to use, how many core he is going to use from the worker, how much RAM he needs, right? All this is optimization he has to consider once he runs that code into production, and he has to engage the admin to tune his machines. So that is the manual work. More code. Generally in industry we prefer less code, so manageability will be easy. But in this case, in Spark especially, even we have the API, still we have to develop code, either in Python, Scala or Java, any language. So that's where we end up with more code. Training curve is longer. So that's where we talked about, right? Spark supports different kind of languages. So one of the language developer have to learn either SQL, maybe R, maybe Python or Java or Scala. One of the language he has to learn, and also he has to learn the API, how to use those API efficiently, so they can process the more data. So it's a little bit bigger training curve for the Spark. API development. Again, Spark comes with the data processing engine. It doesn't come as a API developer or web server. So if you are going to develop the API, better go to different technology, maybe Spring Boot, maybe Java or .NET kind of technology. So Spark is more like a data processing engine. Same thing on the API call. Once we are talking about the API call, let's say for example you have delta table. You want to get API through the delta. If you are using Spark as a build layer, right? Then concurrent accesses may be slow because it's use a JDBC connector. So in those kind of situation, either use Mongo or some other database and directly hit a Java API to those databases. You will get a fast response compared to using the JDBC connector in between. So API calls are slow if users are getting growing fast. Maybe you have 20,000, 50,000. That number of users are hitting in concurrent. It's not a recommended middle layer. Less algorithm, what does that mean? So we talked about Spark support data science, right? So data science needs a lot of pre-built libraries and algorithm. In Spark is not that mature. I will not say mature, but it don't have that much enough library to support all kind of use cases. So these are the basic limitations. I hope you understand what are the limitations on the Spark. Thank you for watching. Please subscribe the channel.